Now my next question is, let A vector is equal to I cap plus K cap, B vector is I cap minus J cap plus K cap, and your C vector is this. A vector V in the plane A and B. So this is the interesting point. A vector V in the plane of A and B. So your figure is somewhat like this. Your figure is somewhat like this. Your vector A, that means your vector A, this is the 1 comma 1 comma 1, this is your A vector, that is I cap plus J cap plus K cap, so its coordinate is this. And another vector B vector, this is the B vector, so this is equal to I cap minus J cap plus K cap. So this is so a vector V in the plane of A and B, your vector V. So your vector V is equal to A vector plus lambda B vector, because you have learned already, that is the to find the equation of a line passing through a point and parallel to a given vector. So that your is R vector is equal to A vector is plus lambda B vector. This you have learned in equation of a line passing through a given point. So from this language we conclude that my V vector is A vector plus lambda B vector. This is the most important factor here. That means your V vector is because in a plane, this is the plane which contains the A vector as well as B vector. So to find a vector V, you have to think in such a way so that I can find the V vector. So V vector, this is in the plane, so this is a line. So your V vector is this. When you can have identified your V vector, rest is very easy. Projection on C vector, that means this B vector you are bringing it in the direction of C vector. So this will be V vector dot C cap, that means you are bringing it in the direction of C vector. So this will be equal to V vector, your C vector is C cap, that means projection on C vector, that means in the direction of C vector, therefore dot C cap. So your C cap is C vector divided by modulus of C vector. So here your V vector is this A plus lambda B vector. So let me make it. V vector, A vector is your I cap plus J cap plus K cap and plus lambda. Your B vector is I cap minus J cap plus K cap. So this is your V vector. So let me correct it, that is equal to 1 plus lambda I cap plus 1 minus lambda J cap plus 1 plus lambda K cap. So this is your V vector. So your V vector according to A vector plus lambda V vector. So your A vector is your I cap plus J cap plus K cap plus lambda. Your B vector is I cap minus J cap plus K cap. So when you arrange it, your V vector is, this is your V vector, that is 1 plus lambda I cap plus 1 minus lambda J cap plus 1 plus lambda your K cap. This is your V vector. So V vector dot C vector. So here this is your V vector dot C vector. Your C vector is given here. Your C vector, that is equal to I cap minus J cap minus K cap. So your V vector dot C vector, this is equal to this comes out to be 1 plus lambda and minus 1 minus lambda and then minus 1 plus lambda divided by modulus of C vector, that is root over 1 square plus minus 1 the whole square plus minus 1 the whole square. So this is, and your this projection it is given to you, that is equal to 1 by root 3. So here uh, here we have to find the v vector. So this is equal to 1 plus lambda minus 1 plus lambda minus 1 minus lambda, and divided by, this is 1 plus 1 plus 1, that is root 3, that is equal to 1 by root 3. Here this lambda cancels out, 1 1 cancels out, so see, minus this cancels out, and this cancels out, so lambda minus 1 is equal to 1, your lambda is equal to 2. So your lambda is 2, so your v vector, will be equal to 1 plus 2 3 I cap uh, minus j cap and 1 plus 2 plus 3 k cap. So here we see that our option C is correct. So here we see that our option C is correct. So this is your answer. This is your answer, and uh, this is your answer. The main technique was to, if you can locate this v vector, then everything is easy, because this language, from this language you have to find out the v vector. I took the help of this because equation of a straight line passing through a point and parallel to a given vector. So this vector, this is the position vector, so this is the a vector and this is the b vector, they are in the same plane. So by the help of this, it becomes very easy to solve it. Now my next question is, let O be the origin and let PQR be an arbitrary triangle, and the S is a point. So your figure is something like this. Your figure is something like this. Yeah, this, suppose this is your PQR. Figure something like this. P, Q, R and O. So here this is your position vector OP vector. Here this is your position vector OQ vector, and this is your position vector. And the point S is such, the point S is somewhere as such that OP dot OQ plus this, and this is your, say, position vector S. This is your position vector S. So here let me see what happens. The point S is such that from this orthocenter, incenter and circumcenter, from this the option given to you, from this I suppose that the point S is inside the triangle from the from the options given here. So I have taken S inside the triangle. So but let us check what happens. These two are equal, that is your OP vector dot OQ vector plus OR vector dot OS vector. This is equal to your OR vector dot OP vector plus OQ vector dot OS vector. This I bring all this side towards left. So your OP vector dot OQ vector plus OR vector dot OS vector is equal minus OR vector dot OP vector minus OQ vector dot OS vector. So this is equal to 0. So let me do something. Let me take this and this. So here your common is OQ vector. So this will be OP vector minus OS vector, and here again your this is OR OP OR dot OP, OR dot OP. So here I take this OP minus OR, no, so here from this I have selected here, minus OR vector, so this will be equal to minus OR vector, so this will be OP vector minus OS vector, so this will be equal to 0. Now here again your OP vector minus OS vector common, so this is OQ vector dot OR vector is equal to 0. So OR vector, OQ vector minus OR vector. So OQ vector minus OR vector. OQ, here you can see OQ vector minus OR vector. If I apply triangle law, OQ minus OR, OQ minus OR, that means if I apply triangle law, what will happen if I apply triangle law? That is your OR vector dot RQ vector is equal to OQ vector. So here RQ vector, that is equal to OQ vector minus OR vector. So this is OP vector minus OS vector, this is RQ vector is equal to 0. Now here again OP minus OS, OP minus OS, this is your OP OS. Again I am applying this triangle law here, so this will be OP minus OI. If I apply triangle law here, OP vector plus PS vector, that is equal to OS, not I have to take in the another way, this direction, then it will be in this opposite direction. So your OP vector, your this OS vector plus SP vector is equal to OP vector. So here your SP vector, this will be OP vector minus OS vector. So this is SP vector dot RQ vector, that is equal to 0. This is your SP vector and this is your RQ vector. This is SP vector, this is RQ vector dot. If you produce it, you can produce it, that means PS vector dot this SP vector dot your RQ vector. This means your SP vector is perpendicular to that means your SP vector is perpendicular to RQ vector. SP vector is perpendicular to RQ vector. Similarly, from these other options, I can find that again this can be done, that your this is a SP vector. The result I got here is that is the SP vector. Let me write here. Your SP vector is perpendicular to RQ vector. This is the result I have got. Now for the second, let me see for the second case what happens for the second case. In this second case, let me see for the second case, that is for the second, let me take, that is OR vector dot OP vector plus OQ vector dot OS vector, that is equal to OQ vector dot OR vector plus OP vector dot OS vector. So if I shift all this towards left, OR vector dot OP vector plus OQ vector dot OS vector, minus OQ vector dot OR vector minus OP vector dot OS vectors, this is equal to 0. So let me take this and this. So here your OP vector, that is OR vector minus OS vector, and again here if I take minus OQ vector, so this will be OR vector minus OS vector, and this is equal to 0. So here this will be OR vector minus OS vector and OP vector minus OQ vector, so this will be equal to 0. Now OP vector minus OQ vector, OP minus OQ, OP, that means this plus this equal to OP, so this will be OP, OP vector minus OQ, that will be this plus this, QP vector, this plus this, so this is QP vector. So here your OR vector minus OS vector dot OQ vector, not OQ, QP, this is a dot QP vector is equal to 0. Now OR minus OS, OR minus OS, OR minus OS, so this is your SR vector, OP, OS minus SR, OS minus SR is equal to OR, so SR vector is OR minus OS vector, so this will be SR vector dot OP vector is equal to 0. That means your SR vector is sorry, this is Q, your SR vector is perpendicular to PQ. So here you will get SR vector is perpendicular to QP. So from this these two perpendiculars are intersecting, so I can conclude that it is orthocenter. So your point is orthocenter, your point is orthocenter. This is your answer. Now here this is my next question. So first of all I must know the expansion of sin x, that is x minus x cube by 3 factorial plus x5 by 5 factorial minus, and it goes like this. So for sine beta x, this will be beta x minus beta cube x cube by 3 factorial, again plus beta to the power of 5 x to the power of 5 by 5 factorial, and then minus, and it will go on like this. So here in this question I am going to put the values of sine beta x and sine x. So here this is not included in a higher secondary course. This sine x, this value is given in your TDC course, that is, it is given in your graduation course. This is not included in your higher secondary course, but such questions are given in advanced, JEE advanced. So let me solve it. Here again limit x tends to 0, your this is x square sine beta x by alpha x minus sine x equal to 1. So here limit x tends to 0, x square, this is beta x minus beta cube x cube by 3 factorial plus beta 5 x 5 by 5 factorial minus dot dot dot, and then here this is alpha x minus your x minus x cube 3 factorial plus x to the power of 5 by 5 factorial minus dot, and this is equal to 1. So here again limit x tends to 0, here this is x square beta x minus beta cube x cube by 3 factorial, that is beta 5 x 5 by 5 factorial minus dot dot dot, and in the denominator, that is alpha x minus x plus x cube by 3 factorial plus plus not, this is minus x 5 by 5 factorial, then this will be plus dot dot dot, and this is equal to 1. So here again we see that limit x tends to 0. If we take x common, so this will be x cube, so beta minus here beta cube by x square by 3 factorial, and again beta 5 by x 4 by 5 factorial minus dot dot dot, and here the denominator alpha common, so sorry, not alpha, x common, so this will be alpha minus 1 plus x cube by 3 factorial minus x 5 by 5 factorial plus dot 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 equal to 1. So here the most crucial point here you see, this is the most interesting and the most crucial point, that if this is 0, then your limit will exist, because if this becomes 0, I can take x cube common here, and this x cube cancels out, and we get a result. If we, this is the most interesting point, this is the presence of mind, if we make this is equal to 0, then only your limit will exist, then only the limit will exist. So what I am going to do is that is your this for the existence of limit, that is for the existence of limit, for the existence of limit, your this alpha minus 1 must be equal to 0, so your alpha comes to be 1. Now this is 0, so here your limit, that is x tends to 0, this is x cube beta minus beta cube x square by your 3 factorial plus beta 5 x 4 by 5 factorial, and then minus dot dot dot, and in the denominator I can take x cube common. If I take x cube common, so 1 by 3 factorial, and then minus x square by 5 factorial, your plus dot dot dot, and this is equal to 1. So this cancels out. Now if you remove the limit, so you will find that all this is 0, this is 0, so only remaining I get is 1 by 3 factorial is equal to 1, that means 6 beta is equal to 1. I am getting 6 beta is equal to 1. So here I have to find out the value of 6 alpha plus beta. So 6 alpha, so this comes out to be 6 alpha plus 6 beta. Your 6 beta is 1 and your alpha is 1, so this is 6, so ultimately your answer is 7. Your answer is 7. This is your answer. The most critical point you have to think here, that this point, this is the most critical point, that means alpha minus 1 must be 0, then only the limit will exist. Now my next question is, let Z be a complex number with non-zero imaginary part, complex number non-zero imaginary part. If this is a real number, we have to find the value of Z square. So how to proceed? How to proceed? Here I try to minimize Z. I first of all try to minimize Z. How can this be possible? So as per this, let me divide it. What happens if I divide this? 2 plus 3Z plus 4 z square 2 minus 3z plus 4z square, because here you see, first of all, to find z square, I am getting no other way. I will try to minimize z. To minimize z, so this fraction, in this fraction I will try to minimize z. So let me first divide it. So this will be 1 times, so 2 minus 3z plus 4z square, so minus plus minus, that is equal to 6z. So this will be 1 plus 6z by 1 plus 6z by 2 minus 3z plus 4z square. This comes out to, when I divide it, this comes out to be this much. So again, I will again try to minimize it. So let z 6z, let me take here z common. If I take z common, so this will be 2 by z minus 3 plus 4 z. This will be this much. So here, sorry, 6z, everything is okay. So your this z and the z cancels out. So the last value I have got this, that is 2 by z plus 4 by z. 4 by z. This is the last value I have got here. So here again I can minimize it, that is 2 common 1 by z plus 2z. So the last result I am getting here is 1 by 2 plus 2z. Now z, we know that z, let z is equal to x plus iy. So I am going to put the value of here. So 1 by z plus 2z. So 1 by z, that is x plus iy, and 2x plus iy. So here x plus iy. So now let me take the LCM. If I take the LCM, this will be x plus iy. Instead of beta, let me here remove this. That is x minus iy by x plus iy into x minus iy plus 2x plus iy. So here this will be x minus iy by x square minus minus, that is plus y square plus 2x plus iy. So if I take LCM here, so this will be x square plus y square, and this will be x minus iy plus 2 x plus iy into x square plus y square. So now that is x minus iy, if plus 2, if I multiply this, I am going to get x cube plus xy square, and then again plus I bracket yx square plus y cube. I am going to get this value. I am going to get this value here. I am going to get this value. So now by x square plus y square, I am going to get this value. So here 2, this is x cube plus xy square, and this will be plus I common plus x, and here this will be minus take I common, so this will be yx square plus y cube minus y by x square plus y square. Because it is a real number, so your imaginary part will be 0. That means your imaginary part will be 0. So here your imaginary part is yx square plus y cube minus y, this is y, by x square plus y square is equal to 0. Now if you take common y here, so x square plus y square minus 1 is equal to 0. So x square plus y square is equal to 1, and this is modulus z square is equal to 1. So this is your answer. So here you see this is the, to solve it I have to minimize the value of z. Only then I will be able to solve it. So this is your answer.